All right, for 17, the best way to start for this one is to construct a game matrix. So we've got the Big Ten on offense choosing run left or right. We've got the defender choosing defend left or right. If the defender defends to the left and the Big Ten runs to the left, the defender will win, Big Ten will lose. If they run left and the defender defends right, defender loses, Big Ten wins. Similarly, if they run right and the defender defends left, the defender loses and the Big Ten wins. And then this is really the difficult part here, is where we've got a probability of winning if they run right and are defended right is 70%. And of course, the remaining probability is the opposite outcome. The defender wins and Big Ten loses. Now, what I did was I set values to wins and losses. I set win equal to +1 and loss equal to -1. I guess you can set any values you want, but they have to be equal and negatives of each other. So from there, we can calculate mixed strategies. I went ahead, you didn't have to do this, but I started doing the work, so I decided to just finish it. But I figured out what the mixed strategy for the defender would be. And basically the way you do that is you're trying to solve for an alpha, right? Alpha is the probability they choose left. Of course, then 1 minus alpha is the probability they choose right. They're choosing an alpha such that the Big Ten player or team is indifferent between choosing left and right. Okay, so basically we start with the payoff of choosing left. Okay, so if Big Ten chooses left, their payoff will be alpha times -1, because they would lose in that case with alpha probability, and then 1 minus alpha times +1, because they would win with that probability if they choose left. So here's their expected payoff if they choose left. We do something similar. Here's their expected payoff if they choose right. It's of course a bit messier because of this probabilistic outcome here, but they will, if they choose right, they will win with alpha probability, and they will get this outcome with 1 minus alpha probability. Now, what is this? This is basically the expected win, right? So they will win basically with a 40, I shouldn't say they'll win with a 40% chance. They'll win with a 70% chance, right? But they'll lose with a 30% chance. So in total, their expected payoff is 0.4, right? Okay, so we can simplify that expression here, simplify it a little further, and then solve for alpha, in which case alpha equals about 23%, okay? So that's what alpha equals. Then of course 1 minus alpha is gonna be, 77%, okay? We do the same thing with the betas, right? So choose a beta such that the defender is indifferent between choosing left and right. So first we set up the payoff if they choose left. It's gonna be beta times +1 plus 1 minus beta times -1, right? So that's their expected payoff from choosing left. We do the same thing, expected payoff from choosing right, and that's what we have here. Looks similar to above. And then from there we just solve for beta, and in this case beta actually equals the same thing, 23%. And then the question asks, what's the probability in mixed strategies that Big Ten chooses right? Well, that's 1 minus beta, so we got to take 1 minus 0.23, which gives us our 77%.